Hello and welcome to Sudoku. Here is a puzzle that was in the latest Sudoku Grand Prix round. It was organized by both France and Hungary, and the Hungarian author György Herke made this greater or different Sudoku puzzle. It was a difficult puzzle, so with 72 points, it was the second higher pointer in the event. And the rule is a very weird one. Whenever you have a digit between two cells, it means that this digit is either the greater of the digits or the difference of those digits. So these two could mean, for example, that you have 1 here and 2 there, because then 2 would be the greater of those digits, or it could be 4 and 6, for example. Well, this wouldn't work actually, because we would need 8 here and 10 here, which is not allowed in Sudoku with the standard rules, I mean. So where do we begin? Well, obviously there must be a 9 in one of those cells, because, well, 9 couldn't be the difference between both digits. And then if you get a 9 here, then 3 has to be the difference. If we get the 9 here, 8 has to be the difference, because it won't be the bigger digit. So there are two scenarios here. I say the scenario where we get 9 here, then this must be a 6, and 4 can't be the bigger of those digits. So then we get a 2. And now there are two options, 5 or 7. But 5 wouldn't work because of this 6. If I put a 5 here, then 6 can't be the difference, so it has to be the bigger digit, but it clashes with this one. So this must be a 7. And in this option, then 6 will be the difference, and this will be a 1. And then 6 won't be the difference because it would repeat the 7 in the columns, so it should be a 6 here, the bigger digit. Now 7 can't be the difference, so it has to be the bigger digit. And 8 can't be the difference, so 8 has to be the bigger digit. And this is a perfectly valid option. Now let's look at alternate reality, where 9 goes into this cell. And you see now that 8 can't be the bigger digit, so it has to be the difference, and we get a 1 here. And here it's a little trickier, because 7 could be the bigger digit, and it could be the difference. So I'm afraid I have to do two separate options, 7 and 8. And in both cases, you see that 6 is not the bigger digit, so it has to be the difference. And we get 1 or 2 accordingly. But now 6 can't be the difference because it would repeat the digit that is here. So 6 has to be the bigger digit in both cases. Now 5 can't be the bigger digit, so it has to be the difference, and it makes a 1 that repeats with this one. So we now know that the red scenario is not the right scenario, and all those blue digits are the correct ones. So that's a neat start. This 3 now puts a 3 in one of those cells. And the options here are now 4, 5, and 8. What happens here is that we have a sequence of 4 consecutive digits. And if you look closely, they can't use 8 or 9, because then we would need a 7 in the sequence. So 8 or 9 are in these cells. This is an 8, So we get 9 here, 8 there, and it pushes the 3 here. We can remove 8 from those cells. So now this sequence is 2, 3, 4, and 5 in some order. And we can't know which way around yet. We also need 1 and 4 somewhere here. Then what will we see? 9 here, 9 there. There has to be a 1 here or there. And something interesting should happen here with those two, because they can't all be differences, or can they? 1, 3, that wouldn't work. 1, that wouldn't work. If all of those were differences, then we would have 1, 3, 5, 7, 9 in some order. But those digits prevent that from being the case. So they can't be all differences, so there has to be a case where the 2 is the bigger digit. So there has to be 1 and 2 somewhere. And because of those, 1 and 2 must be around here. But there are 2 options then, because 2 here becomes now the difference. So one scenario is this, and we get this scenario. But if this is an 8, because of these 2 we get a 6 here, which clashes with this. So this is this scenario. And now this has to be 5 or 9. 1 is the difference. So this is an even digit, which can be 4, 6, or 8. And this is an even digit, this is an odd digit, sorry, and it can only be 7. So we remove 4 from the options in this cell. Oh, I didn't mention it, but those clues spell 2021. This is very nice. There's a real sense of the graphical theme with György Herke. This has to be done as well. Perhaps I should first see that 6 here is in one of those cells. Not sure it will be so helpful. Is there any easy deduction? I really don't think so. Something interesting is that if this is a difference, then it won't be between 2 odd digits, because only 1 and 5 are available on this row. But it can still be a difference between 2 even digits, but it won't be 6 and 8 because of this. So the options are 1 and 2, 2 and 4, 4 and 6, and I think these are the only options. What else can we do? I think we must address this S. Well, something interesting is that there's a 4 in one of those cells. I'm not sure how interesting this is actually, but this cell can only be 6 or 8. That's not so interesting. actually, we know that both 6 and 8 are here because of this. So this is a triple, and this cell must be 1. So we have 2, 4, or 5 here, 6, 8, 9 here, like this. Well, that's not a real breakthrough, but I thought it was worth noticing that. And this 5 makes this a 4 and this a 5. Well, that had to be seen. Okay, so let's focus on this. I'm noticing that there must be a 1 in one of those cells. And if I make this a 1, then this is a 2, 4, 6. Let's have a look. If this is a 1, then this can't be a 3 because of that. Then this has to be a 2. Then this becomes a 4. That's a 6. That's an 8. And now this can't be a 9, so this must be a 7. And this has to become a 6, and 6s clash. So this is not a 1, and 1 goes here. So now we know that these two are either 2, 4 or 4, 6. And there's a 4. So this is not a 4, this is a 4. And 1 goes here. It's the only place on this row. So there has to be a 4 here. And again, it will be a matter of which scenario is possible. So there are not that many options. So there are quite some options, but I think we can rule this one out. Sorry, because there's no option for this cell. So this one is not a 6. Would 4, 6, 8 work? No, it wouldn't. That would need to repeat the 6. So this is actually a 2, 4 pair, and this is a 5. That's a 2, and it disambiguates all of this. And here we get 1, 7, and 6. No, sorry, that's 1, 7, and 2. So this is a 7 with a 1, 2 pair. And the value of this cell is interesting. It must be 3, 5, 6, or 8. Oh, that's too many choices. Let's do it here. So this is a 2, 4 pair, so this is 6 or 8. And just notice that 2 and 4 are not here, so they must be there. And there must be a 3 here. That won't be very useful. So how does it work? 4 and 2 wouldn't work because there would be no choice here. So this is 2, 4, 6, 8, and then 6. And then 7 is not available, so this is a 5 and this is a 4. And this is a 3. Nice. So that's definitely a breakthrough. This is a 3. 5 or 9 here. 7 or 9 here. 5, 7 or 9 there. And now it's all good old classic Sudoku. 6 and 8, that's a 9. This is not a 9. 6, 8, and 3. But there's a 6 up there, so this is 3 or 8. What else do we get? 7, 9, 8 or 3. 3, 8, so this is 7 or 9. And 8 and 3 this way. So 8 is not here, 8 is here. Pushes the 6 up. Those must be 4 and 9. I don't have them yet. 4, 9. This is a 5. And this is a 9. That's a 7. That's a 5. This up there is a 9. We get this 5. This 6. And this 8. 4 and 7 here. There's a 4 there. That's a 2, that's a 6, and down there we get 9 and 7. That's correct. 2, 4, this can only be an 8 now. 3 and 9 here. Up there it was 4 and 9, I seem to remember. Oh, but this 8 gives us the 3. That's not a 3. That's not a 6 either. This is a 9. That's a 4. 9, 3. That's a 2. That's a 4. And we need a 7. It's here. And we get this 5. This 8. This ambiguates the 6-8 pair. Let's do this 8 nicely enough. We still need a 2 and a 6. There's a 6 here, so that's 2, that's 6. This is 1, this is 2, and the remaining digits are 1 and 4, and it works. So this is a way to solve this greater difference Sudoku puzzle by György Herke, which was really tricky, but very, very well put. There was this weird elimination here, but that seems a logical way to start. And you see that 3, 4, 5, 6, 6, 7, 8, 9. Even here, the attention to details is really, really wonderful. Thanks for watching this video. See you soon on Sudoku.